All right, this is lesson 4.2, determining slope and y-intercept. And just as a reminder, if you need to pause to write or need me to slow down, you have that ability to pause, rewind, fast forward, whatever. So we are talking about the slope and the y-intercept of an equation, and then being able to graph that. So the first word you need to know, the definition is the y-intercept. Intercept. And for my football fans, you know what an interception is. And so a y-intercept is simply the y-coordinate of the point where the graph intersects the y-axis. And then the x coordinate of this point is always 0. So, for example, if you had a graph and 1, 2, 1, 2, 1, 2, 1, 2, and let's say you had a point right here. Okay, if that's 1 and that's 2, then the y-intercept equals 2. So in here it would be, we call the y-intercept b equals 2 because it's on the y-axis at 2. And the coordinate would be 0, 2. Okay, so b is the y-intercept. Why? I don't know. Okay, so that's an important thing for you to know. And then we've already talked about the slope-intercept form, but I want to have you write it down again because you're going to be using it a lot. So y equals mx plus b. And you know all of these symbols. The m is the slope. And we just talked about b. B is the y-intercept. And then x and y are going to be the values that we're going to be solving for. Okay, so this is called slope-intercept form. I'm going to use a different color. And this is definitely a term that, or a formula that you're going to want to memorize, because you'll be using it a lot. It could stand out in your notes because you can always use your note on a test or a quiz. Okay, so y equals mx plus b. And we know that a linear relationship has a constant rate of change. You can find the rate of change m, right, or the slope, and the initial value b for a linear equation from a table of values. And so that's what we're going to be looking at today, is a table of values. So here's an example I want you to write down. Remember, if I'm going too fast, you can always pause. But we have a phone salesperson is paid a minimum weekly salary and a commission for each phone sold. So we're going to make a table of that. So then we need to first confirm that the relationship is linear or constant. And give the constant rate of change and the initial value. Okay, and so here's our chart that shows her earnings. Ooh, that's on a straight line. That's fine. No, it's not. Okay, so we have the number of phones sold, and then we have her weekly income in dollars. Okay, so when she sells 10 phones, her weekly income will be $480. So that means her base pay, her weekly salary, and commission, her total will be $480. If she sells 20 phones, her weekly income will be $630. If she sells 30 phones, her weekly income increases to $780. And if she sells 40 phones, her weekly income becomes $930. Okay, so the first thing we need to do is we need to confirm that the relationship is constant. I'm not going to make you write it again, but that's our step right here, right? So confirm the relationship is constant. So that's what we're going to do first, and we're going to use a formula that we learned previously, which is the slope formula. And remember, that's the difference in the y's minus the difference in the x's. So it's going to be change in income over the change in phone sold. Okay, so if you remember, that formula is slope equals y2 minus y1 over x2 minus x1. Okay, so our change in income, that's going to be our Y. And our phone sold, that's going to be our X. So now all we have to do is assign values to these numbers and then do some basic arithmetic to make sure that we have a constant, because if we don't have a constant, then this is not going to work. So change in income. So we're going to look at these two first. So the change in income is going to be 630. That's our Y2, right? Y2 minus 480 over, and then our difference in phones sold. So that's our X's. So 20 minus 10. Okay, and then if we subtract, we're getting really small here, we get 150 over 10. And then we can simplify that to 15 over 1, which is 15. So the difference between these two, the constant, is 15. Now it works for that one, but we have to make sure it works now for, choose a different color. It has to work now for this one. So we're going to do the same thing. So take the change in income over the change in phones sold. I'm going to pause this and let you figure it out, and then we'll move on. Okay, so go ahead and figure out the difference between these two and then these two. Okay, so I have gone through and I've found the rate of change in all three groups. So in between these two, between these two, and between these two. And I got 15 for all of them, and I hope you did too. So this is our first step. We have to make sure that the rate of change is constant. So step 1, make sure the rate of change is constant. And it is here in this case because it's our constant is 15. Okay? So now we're ready to go on to step 2. I'm going to switch pages, but you probably will still have room. My iPad's just smaller. Okay, so now step 2 is going to be to find the initial value when the number of phones sold is 0. Okay, so that's step 2. In other words, in this situation, what is her base pay if she doesn't sell any phones? If she just shows up for work and exists, then what is her base pay? So step 2, we're going to find the initial value. When the number of phones is 0. Phones sold is 0. Okay. So we're going to look at our data in our chart, and we're going to add 0 as the number of phones sold, and then we're going to work backwards. So let's make another chart with the same information as the first one. I'm going to rewrite it on here. You can add, if you want to add to your other one and just add a column, you can, but I'm have to do it again. So number of phones sold okay, so we know that we're trying to figure out 0. We don't know this yet, but we know that there's 10 here, 20 here. We could go on forever following that constant because we know that it's constant. Okay, so number of phones sold over her weekly income. Okay, so we know that if there's 30 phones sold, and we know this from the chart that was given to us that we've investigated, we know that she makes $780. We know that if she sells 20 phones, she makes $630. We know that if she sells 10 phones, she makes $480. And we don't know yet what our weekly income is. That's what we're trying to figure. Sorry, what her weekly income is without selling any phones. So that's where we're going to do just a little bit of arithmetic. So we're going to work backwards. We're going to start here at 30. And to get from 30 to 20, we subtracted 10. Okay, then from 20 to 10, we subtracted 10, and 10 to 0, we subtracted 10. Okay, now we're gonna look at the bottom. To get from $780 to $630, what did we do? We subtracted $150. Okay, and to get from 630 to 480, this is why it's really important to know if it's a constant, because that just makes it easier for us, right? It's going to be the same, 150. And then if we go from here to here, it's going to be 480 minus 150. And that's going to be our answer. So 480 minus 150. So her base pay, her initial value, is $330. So the initial value is $330. The salesperson receives a salary of $330 each week before commissions. Okay, so that's our answer. That's our initial rate of change. So we need to know that the rate of change is the same thing as slope. Which equals our m in our equation, y equals mx plus b. And then the initial value, which in our example was her weekly income without any phone sold, just what she gets for coming into work. That's our initial value, which is also our y-intercept. Which is our b in our equation. Y equals mx plus b. Okay, so now I'm going to give you y and x, a table with y and x, and we're going to find the slope and the y-intercept. So let's say for our x's, we have 2, 4, 6, 8, and we have 22, 32, 42, 52. So it's really easy in this chart to see the patterns that they are constant, right? Because these on the bottom, the y ones go up, increase by 10, and the top increases by 2. So we need to figure out what our slope is and what our y-intercept is. So to find the slope or the rate of change, we're going to use our slope formula, which is, let's get our formula straight. So this is y-intercept form. And then this is a review from module 3, but we have slope form, which is, do you remember? The difference in our x's over the difference in our y's. I just said the opposite, the different over the difference in our x's. You knew what I meant. Okay, that equals our slope. Formula. Okay, so that's slope formula. All right, so let's find our slope first. So we're going to take these two values, 22 and 32, and we're going to subtract y2. So we're going to call that 30, we're going to call it 32y2 minus 22 over the difference in our x's, which is 4 minus 2. So 32 minus 22 equals 10, and 4 minus 2 equals 2. And if we reduce that, we get 5. Okay, so this is slope formula, so our slope m equals 5. Okay, so we've done half of it. Now the next part, we need to find the y-intercept. And if you remember from the example before, we are finding the initial value, which is going to be whatever is here when x is 0. Okay, and so we're just going to work backwards from here. So 52 to 42, we did minus 10. 42 to 32 was minus 10. 32 to 22 was minus 10. And 22, we're making an extra column right here. It's going to still be minus 10. And 22 minus 10 is 12. So our y-intercept, which is the same thing as b, equals 12. So then if we were to write that as an equation, if we were to plug that into our y-intercept form, it would be y equals m, which is 5, x, or coefficient, plus b, which is equal to 12. So that would be our equation, and that would be how we would find how to graph different points. Okay, so just plugging in these numbers, we got the b from there, we got the 5 from there. Okay, we're gonna try one more. I'm gonna switch back to purple because red's aggressive. Okay, so we're gonna have our x values and our y values. And we're gonna have, I'm just gonna put this in here for our, when we find our b, so that's gonna be our 0, just to get ahead. Okay, so we're gonna have x equals 1, x equals 2, x equals 3, x equals 4. Okay, we can see that in the top at least, that's constant. And then the bottom, we're gonna have if x equals 1, y equals 8. If x equals 2, y equals 15. If x equals 3, y equals 22. And if x equals 4, y equals 29. Okay, so we're going to, we already know that this is constant because it's minus 1 each time. Let's check the bottom. 29 minus 22 is 7. We're subtracting 7. 22 minus 15 is 7. 15 minus 8 is 7. 8 minus 7 is 1. Okay, so here our slope no, that's our y-intercept. Sorry, I skipped ahead. I confused myself. Sorry. Our y-intercept, right, because that's the initial value. Sorry, it's like 10 o'clock and I'm fried. Okay, so that's our y-intercept. So b equals 1, right, because that's the y right here. When x is 0, b equals 1. And then to find our slope, we're going to use slope formula. So I'm just going to take 4 minus 3 on the bottom and 29 minus 22 on top. 29 minus 22 is 7. 4 minus 3 is 1, which equals 7. So our slope is 7. Okay. Hopefully that makes sense. If you have a specific question, please ask it. But that is how that's how you find the slope and the intercept. We're going to go on to your independent practice, which is on page 106. So in your guided practice, instead of giving you a table, it's giving you a graph. And if you remember, we can find, we have 2 points right on the graph, and we do rise over run to find our slope. So if we take this guy and we're going up, how many? 1, 2, 3, 4 rise, and then over 2, 1, 2. Okay, so our rise was 4, our run was 2, and 4 halves is the same as 2. And since it's going this way, it's a negative slope. So our slope is -2. Okay, so we got the slope from rise over run. Then for our y-intercept B, remember that's just where it crosses the line, where y crosses the y-axis. And so we can just see from right here that it's 1. So our slope is -2 and our y-intercept is 1. Now you might be wondering, why did we do all that work making a table on the examples if we can just do our rise over run trick? And that's a great question. Several different ways to do things. And if we would have graphed those points, we could do it this way. So some of you, this is going to be easier for you. Some of you, the table in arithmetic is going to be easier, but we're going to learn how to do it both ways. Okay, so number 2, our slope is rise over run. So we're going to start here at this point, and we're going to go up. How many? 1, 2, 3. That's our rise, and then our run is 1, 2, 3. So, but sorry, these are 10, coordinates of 10. So that's not, that's 15. So 15, 5, 10, 15. And then run of 3, because these count by ones. Okay, so 15 over 3 is the same as saying 5. So our slope is 5. And then our y-intercept, that's where this crosses the y-axis, is 0, -15. And so the y-intercept is -15. I'm going to have you do 3 and 4 on your own. If you want to pause this and do those, you can. But I'm going to go on to number 5 and have you do 6 on your own. So number 5, find the slope and y-intercept of the line represented by each table. So that's just what we did. Oh, look, it's giving us our 0 here. It's giving us our initial what was that called? I gotta go back in my notes. Our initial value. It's already giving that to us. So we just have to figure out the difference. So we're gonna go backwards from 8. So 8 to 6, that was -2. 6 to 4, that was 2, 2, 2. So that makes our y, and then the y's, we're subtracting, we did 6 there, 6 there, 6 there, 6 there. Okay, so that makes our y-intercept 1. I'll write it down here because I wrote a bunch of notes there, right? Because when x is 0, y is 1. So that's our y-intercept. And then we need our slope. And so we can do the difference in our y's over the difference in our x's. So I'm going to take these last two and do, first of all, our y's go on top. So 25 minus 19 over 8 minus 6. 25 minus 19 is 6. 8 minus 6 is 2. 6 halves reduced is 3. So our slope is 3. And if we were to write that as an equation, we could do y equals mx plus b. Our m is 3, x plus, and our y-intercept is 1. That's where it's going to cross the axis. And then I'm assuming that next lesson we'll learn how to graph from this equation. Won't that be fun? All right, so I want you to do numbers 3, 4, and 5. Nope, 3, 4, and 6 on your own. And let's look at the last essential question together. It says, how can you determine the slope and the y-intercept of a line from a graph? Well, we just did that. First, we find the slope of the line. Using the coordinates of 2 points on the graph. Then find the y coordinates y-coordinate of the point where the graph crosses the y-axis. So to determine the slope and the y-intercept form from a graph, which we did in number 1 and 2, we find the slope of a line using the coordinates of 2 points on the graph, then find the y-coordinate of the point where the graph crosses the y-axis. That's your y-intercept. All right, you are ready to do your PMTs after you finish this guided practice, and I will look at it and give you credit for finishing your notes and your guided practice when I get back, and you're ready to go on to your PMT when you're done with that. Thanks so much for listening. You're awesome. Love you, miss you. Have a great rest of your day. Bye-bye.